Hello, good morning, good afternoon, good evening, everyone. Welcome to this masterclass session on logical reasoning of the ACET paper. My name is Kevin Punmya. I am a qualified chartered accountant and a qualified actuary of the Institute of Actuaries of India. I've been working as an actuary for over the last 5 years in multiple consultancies, and I'm also a passionate teacher. So I've been teaching actuarial science at a private coaching in Mumbai. Today's session focuses on the logical reasoning section of your ACET paper. So if you are aware, ACET has predominantly 5 sections, that is your mathematics, statistics, data interpretation, logical reasoning and English. 4 technical ones are obviously, if you exclude the English, then the 4 technical ones. Today we try to cover the logical reasoning section of ACET and understand what is the content, what is the sort of syllabus, and how you go about writing these questions in exams. Obviously, ACET is a multiple choice question, so all the questions are MCQs. And I thought the best way to do a masterclass session on logical reasoning would be to solve past exam questions, right? Because I don't want to go into syllabus or coverage or stuff like that. All of that is directly covered along with exam level practice when I solve past exam questions. So what I've done is I've extracted the logical reasoning section of last 4 ACET diets, and I will try to solve these with you. I will walk you guys with how you're supposed to think, how to actually best navigate those questions, and how to make those quick decisions, logical decisions in the exam. Because the key is not to just write the correct answer, the key is to write the correct answer in a relatively short span of time, because ACET is a time bound exam. Okay, so let's get into it. Yes, so let's begin the logical reasoning masterclass. Good thing is, when we cover the entire paper, you will realize, there will be a mix of easy questions, difficult questions. All of that you'll be able to realize when we do these past exam questions. So let's start with the latest diet, that is the August 2025. Let's get into it. So the first question says, Rahul introduces Priya saying, she is the daughter of my grandfather's only child. Okay, how is Priya related to Rahul? So let's quickly, don't try to do like a mental mathematic kind of a thing over here. Don't try to make mental notes. Just write it exactly what they are saying and you should be good to go. Okay. So Rahul introduces Priya. So Rahul, Priya. Now who's Priya? She is the daughter of my grandfather's only child. So Priya is someone's daughter. Let's call it X. And that daughter is of whom? It is of my grandfather's only child, which means Rahul's grandfather. So this is Rahul's grandfather, and the grandfather has an only child. So the grandfather has a child. Let's call that child Y. Because it is Rahul's grandfather, so the only child is obviously related to Rahul, that is, it is his father or mother, and grandfather's only child. So that would mean that, let's say if this is the father is the grandfather's only child. Priya is the daughter of that particular person, which means in our case X and Y are the same, correct? Because daughter of grandfather's only child. So this means that X and Y are same, which means Rahul is the son of a person and Priya is the daughter of that same person, which means Rahul and Priya are brother and sisters. So Priya is the sister of Rahul. And that's what we have here. That is, your answer is B, correct? So this is how you can just break down these complicated or looking complicated questions into just smaller steps, and you should be good to go, correct? Another way or another trick to do this is always, personalize it. Like, okay, Priya, I'm introducing someone. Now that someone is the daughter of my grandfather. So you can think of your own grandfather in this case if you don't want to use X, Y and all of that. So okay, my grandfather, and let's assume he has an only child. Okay, and this Priya is the daughter of that child. So that way also you can make a note or make a chart and you should be able to do it. Okay, so that was a good start. Let's move to the next question. So it says, if September 15th 2029 is a Saturday, what day of the week will December 31st 2029 be? This is again a very common type of ACET question, and a mistake, or in my understanding a mistake would be, if you go on to directly just calculate number of days gap between them. The way you should always calculate which day it is type questions, in my opinion, is something like this. So here we have both of these dates in the same year, 2029. So it's the months that we have to calculate. So 15th September is a Saturday. Now the way I will want to do this is, I know a week has 7 days, which means if I add 7 to this, I will get the same day. So for example, 15 plus 7 is 22. 22 September will also be a Saturday for sure. Ideally, try to go till the end of the month. So let's say if I add 7, I get 22. But if I add 14, which is 7 into 2, so if I add 14, I get 29th September, which is end of September or near the end of September. So 29th September would also be a Saturday, which means 30th and then 1st of October will be Sunday, and this will be a Monday, correct? So I jumped into the next month. Similarly, now in October, let's go to the last week of October. So for example, if I add 28 here, can I say I'll simply get 29th October, and this should also be a Monday, correct? So small steps, you just basically go from the start till the end of the month, and that's the best way to ensure that the calculation of days is correct. Otherwise you may get confused one day here and there, and then you will get a wrong answer, because it's MCQ, right? Only one of these is correct. So Monday, Tuesday, how will you know which one it is? So 29th October is a Monday. So then we enter 30th October, 31st October, and then finally 1st November. So Monday, this will be Tuesday, Wednesday, and this is definitely Thursday. Again, we have to go to the end of the month, so we can add 28 days. Always add the days which are multiple of 7, so that you'll get the same day. So 29th November will also be a Thursday, which means 30th November, and then you come to the target month, which is December. So 1st December will be Friday, and this will be Saturday. And now we want to go to 31st December. So again, you have to go to the end of the month. So that will be plus 28, which will be 29th December, and that's a Saturday. So 30th is a Sunday, and 31st December is definitely a Monday. And this is your answer. So answer would be option A, that is 31st December is a Monday. For now, you can cross check these things with calendar and whatnot. Obviously in exam you cannot do that. So simply your answer here would be answer A, correct? So which day type of questions are common? You should know this tricks to do it, right? Obviously you cannot do like the entire calculation on hand, like Saturday, Sunday, Monday, like that. It does not make sense. Rather, this 28 days leaps and just going till the end of the month and a multiple of 7 is the short way to be able to calculate it. Yes, it takes about a minute, but at least you are accurate, correct? And you get 2 marks out of it, so that's good. So that was question number 64. Let's move to the next one. Question 65. So the pattern of figures as follows. Now usually these types of questions do give the pattern of figures as well, but here to add complexity, to add a layer of difficulty, they have written these names, so we can try to figure it out. So we have a black triangle, so I'll just quickly start creating them. Black triangle, I'll just write B inside to show this is black. Then you have a white square, so although I am using a black marker, but this is white, so I'll just write white inside. Then a black pentagon. Pentagon means something with 5 sides, so something like this. This is black. Then you have a white hexagon. This is something with 6 sides, so that's a hexagon, and this is white. And what color and shape would come next? So you don't need to draw it also. You can see 3 sides, 4 sides, 5 sides, 6 sides. So the next one has to be a 7-sided figure, which is called, sorry, we have the next as black heptagon. So we do have one more. I thought we were done here. So we have a black heptagon. So that's a 7-sided figure. So 1, 2, 3, 4, 5, 6, 7. Like it's something like this. It's much better than this, but okay. Black. But now obviously the next one will be a white, and a white figure with 8 sides. So that's simply an octagon, because you see hexagon was 6-sided, nonagon is 9 sides, octagon there are 2 options. So which one would come? So you can see black and white are oscillating between them. So the last figure was black, this one would be a white octagon. So that will be option A. Correct? So relatively straightforward 1-mark question. All you need to be aware of is first, what is the name of an 8-sided figure? That's an octagon. Okay. With that, we move to the next question, that is question 66. So it says 5 colleagues R, S, T, U, V are sitting in a straight line, all are facing north. Okay. So question 66. You have 5 colleagues R, S, T, U, V. We will write how they are seated now. S does not sit at any end. Okay, so I'll just write the word S somewhere in between. So obviously there are positions 1, 2, 3, 4 and 5. S is somewhere in between, not necessarily 2, 3, 4, 5. We'll assign those numbers later, but yeah. So S is somewhere in between. U sits second to the left of V. Okay. R sits to the immediate right of T. V is not an end. Okay, so let's try to make this. U sits second to the left of V, which means wherever V is sitting, you can leave a space and then U will be there. Okay, so U dash V. We are told V is not at an end, so there will be at least 1 or 2 spaces after V. Okay. R sits to the immediate right of T. So now, if there is 1 or 2 spaces after this, R cannot be here because R is to the immediate right of T. So R cannot be here for sure. R cannot be here because if R is here, that would mean T is here, which would mean V becomes an end. So absolutely not the case, which means R is definitely here and this is T. So you have U dash V T R. Are we contradicting anything? No. U sits second to the left of V. Yes. R sits to the immediate right of T. Yes. V is not at an end. So V is not at an end. And finally S is not at an end. So this S goes here. So S is not at an end. And this is the sequence in which they are sitting. U, S, T, V, R. Okay. So who is in the middle? So you can clearly see V is in the middle and that's your option B. Correct? So again, just write it down, follow those rules and you should be able to get these type of answers. You don't need to overcomplicate by thinking something and all of that. Just logically place them somewhere and you should be able to get the answer. Perfect. That was question 66. We then move to the next one, that is question 67. So again, logical reasoning questions. This is a quite common type of a question. It says some engineers are musicians. All musicians are dancers. No dancer is a scientist. Okay, so let's quickly just try to create a Venn diagram or something. So some engineers are musicians, which means you have a lot of engineers and some of them are musicians. Okay. Some engineers are musicians. It does not mean that musicians are only engineers, right? So I'll just correct this particular diagram here. So I will say that this means some engineers are musicians. Now musicians could be anything. They could be engineers, they could be non-engineers. All musicians are dancers. So all these musicians, the same line applies for dancers as well. So M/D, because all musicians are dancers. But again, the vice versa is not true. That is, dancers could be musicians or non-musicians. So one way in which you can do this is you can create a circle which is bigger than M, which contains the M circle, and this bigger circle is D. Okay. And finally, no dancer is a scientist. So there is another circle altogether which will not contain any dancer. So dancer is definitely not scientist. Dancer could be an engineer. Dancer definitely cannot be a musician because all musicians are dancers, right? So you will have a circle completely apart from this, which is a scientist. Now it's your choice. If you like Venn diagram, you can do this, or you can just go with the natural flow of the questions, whichever way you prefer it. But with this, now we are not contradicting any of the statement, and now we can go on and find which is the correct option. So now let's go to the options and see. It says some engineers are definitely not scientists, and that is true because you can see some engineers, which is this musician engineers or the dancer engineers. So just highlight that for your reference. So these musician engineers, they are definitely not scientists, which we can see. So option A is correct. Because you have all of the above, we'll have to read the others as well. All musicians are not engineers. So that is true. We are told some engineers are musicians, but that means there will be musicians which are not engineers, and that's precisely what you see in this Venn diagram here. That is the green portion. These are musicians who are not engineers. So that is true. All musicians are not engineers. Some of them are. And C is some dancers are engineers. Again, that is true. Some dancers are definitely engineers because you have this entire section in blue, and all of these are dancers and they are engineers. So some dancers are engineers. So accordingly, your answer is obviously option D, that is all of the above, which means we will go with the answer D because all three statements are true. Okay. So yes, this type of Venn diagram could help you, or just evaluating the statements by its face can also help you. If all okay, we move to the next one. That is again a cryptography type question, one of the common ones in ACET logical reasoning. Let's try and understand. It says if action is coded as BDUJPO and react as SFDBDU, how is teach coded? Okay, so you don't need to try and code out every word. Just look at what we want. We want teach. So the first alphabet is T. Do we have T in action? Yes, T is in action. So just simply action, and we write it as BDUJPO. And finally you have react, and that we are writing as SFBDU. Okay, so we want the first letter as T. What is T? You can see your third word is T in action, which is U, and over here fifth letter is T, which is again U. So T is definitely U. So before trying to write the other words, let's go to the options. We have two options, A and C, which start with U. So the answer is definitely either of them. So now instead of trying to code out the rest of the word, let's look at these options first. So you have UF, here also UF, then here you have BDI, and here you have DBI, which means the only difference between these options is the third and fourth letter. So let's try and directly code out the third and fourth letter. So in teach, the third letter is A. So what is the letter for A? So A in action is the first one, which is B. A in react is the third one, which is also B. So the third letter is U dash B. So which of these two options is that? So that's option A. So you can just try and check. You can code out your option A would be the correct answer. So answer is option A. And that is precisely the point of logical reasoning questions. You can do the hard work of writing each letter, okay, what is A stand for, what does C stand for, and all of this, or you can just do the minimal way of getting the answer, which is find the first one, narrow down your options, and then between those options which would be the correct one, just try and reverse engineer that. Much quicker. Okay, so that was your question 68. We move to the last two questions of the August 2025 diet. So again, a very common type question, which is find the next number in the sequence, and you're given a sequence. So let's look at this sequence. Question 69. 10, 18, 33, 55, 84. Correct? Now these sequence type questions you have to find the next one. These sequence type questions, obviously there's no formula to get the answer, right? It's just a logical way to look at it. Things that you should keep in mind are always find the difference and see if there is a pattern in the difference. Find the pattern in the difference. If there is a direct pattern here only, then you can look at those. So common patterns are like perfect squares, cubes, some polynomial equations, like something like, not a very difficult one, but something like, example, 2x plus 1. So each number is twice your current number and then you add something or you subtract something. So 2x plus a type of thing. So these types of equations you can try and find, and usually among these you should be able to find a common pattern. Okay. So first, as I said, always let's find the difference. So here the difference is 8, 15, this is 22, this is 29. So what are the differences? Your differences are 8, 15, 22, 29. Can you find a pattern here? Directly maybe not. So again, then just let's apply the difference. So here it is 7, 7, 7. And there's your pattern. That is, the difference is increasing by 7. Which means the next difference would be 36. So you just need to add 36 to the last number and you should get your answer. That's 120. So that's it. You don't need to overstress or overthink a lot. Difference, perfect squares, cubes, polynomial equations, and those should be good enough in most cases. Okay. So here the answer is option D. That's 120. Correct. And a practical advice. So these type of questions, they look very appealing, right? You want to get this right. In some cases, what I've seen in exam is it's a 1 mark question. There may be an obvious pattern, but you have thought about for 2-3 minutes and it's just not clicking. You're just not able to understand what is the pattern. Sometimes very elementary errors happen because of which you're not able to understand. Don't waste a lot of time in this question, right? Because if you don't get it once, for example, you may just waste time which you could have otherwise used in questions that you knew. So I understand it's very appealing. You want to get this type of questions right. If, for example, here it was very direct, okay, difference, and we got the answer. Sometimes if it's too difficult, too complicated, and you're just not able to understand it, move to the next one and keep this question for the last. So in the last, if you have time, come back to this question and think as much as you want, right? Anyway, logical reasoning is usually at the end of your ACET. So if you're following your sort of consequential sequence, then it should not be an issue. Perfect. So that was question 69. Now we move to the last question of August 2025, logical reasoning. So you have 6 people, Nina, Omar, Priya, Raj, Surya, Tia, and they are sitting in a circular table, all facing the center. Okay. So question 70, you have a circle and there are 7 spots, right? 6 people. Okay. So 1, 2, 3, 4, 5, 6. Just for my reference, I've created it. Priya, now because it's a circular one, no, you don't need to worry about edges. So you can just start plotting people. Priya sits to the right of Tia, which means if Tia is here, then to the right would be this one. So here you would have Priya. Okay. So Tia, then on the right you have Priya. Understand, the right means Tia's right? Okay, so Tia is seated and her right would be this way. I can imagine you thinking that, okay, the right, but I just created an arrow to the left, but just imagine you're sitting in a circular table and that's why the right would be, for 1, the right would be 6. Okay. Raj is not adjacent to Priya or Surya, which means Raj is definitely not here. That's all we know. So he's not adjacent. Anyway, one side adjacent is Tia. Here we definitely do not have Raj. So I'll just write here R is not here. And he's not adjacent to Surya also, which means Surya is somewhere, but Raj is not adjacent to Surya. Let's first try and find Surya and then we'll plot Raj. Okay. Nina is between Omar and Surya. Okay. So we have Nina. who again will definitely not be here. Nina is definitely not here. Why? Because Nina is between Omar and Surya. You have Priya over here. Nina is also definitely not here because here you have Tia. So Nina is somewhere in between, which means she's either here or she's here. Okay, Nina could be either 3 or 4. Raj, again let's go back to Raj. Raj is not adjacent to Priya or Surya. Okay, so we have Omar, Surya and Nina and we need to place them in. We know Nina is not here nor here. What if Nina is here? If Nina is here, let's assume if Nina is here, Omar and Surya have to be next to them. So let's say Surya could be here and Omar could be here. But in that case, Raj is nowhere because Raj cannot be at 5 and that's the only spot left. So this is definitely not the case. So this is a trial and error approach, which means let's say Nina is here. Now if Nina is here, then can we have Omar and Surya here? So here Nina is not there, Raj is not there. Let's have Surya over here and let's have Omar over here. Now the only one left is Raj. Can Raj be here? Yes, nothing stops Raj from being here and that's your sequence. So Priya, Tia, at 2 you have Raj, at 3 you have Omar, at 4 you have Nina and at 5 you have Surya. And you can just check all the cross check all the requirements and all of these are true. So nothing is being contradicted, which means now we can just find who sits to the immediate right of Surya. Surya is here. Immediate right to Surya is Nina. So that's option D. And your answer here is option D. Understood, people? So these are the type of questions you can expect in logical reasoning. I hope everyone followed the logic correctly and I hope you guys are confident enough now to understand, okay, this is the type of questions we should expect, this is how we should quickly try and do it. And if all okay now, then we move to the next diet, that is your March 2025. Before that, just a quick note on ACET. So ACET, that is your Actuarial Common Entrance test, is a very good and very interesting examination conducted by the IAI. For those of you, I assume almost all of you want to become actuaries, right? You want to start your career as an actuary. But you're still in the figuring out phase that, okay, is it something for me or not? The best way to do is the ACET examination. Why? Because in ACET, your subjects, as we just saw, are math, stats, data interpretation, logical reasoning, English. You don't have to study a lot in this case if you think about it. All the curriculum corresponds, most of the curriculum corresponds to your 11th, 12th mathematics, statistics, and data interpretation, logical reasoning are just your normal entrance exam tests. What you gain out of ACET is while preparing and while actually giving this exam, you realize how real life actuaries will be thinking, correct? How do you apply maths? How do you apply stats? How do you solve problems? How do you apply logic like we just saw? These type of things are, I can tell you, day-to-day decision-making questions for a professional actuary. And that's why ACET is quite good and quite interesting, because when you give this exam, if you like it and if you appreciate the type of thinking you have to do, the type of analysis you have to do, then you are certainly apt for becoming an actuary, because the actuarial journey is a long one. You enter it, you should not enter it basically without knowing where your end goal will be. So ACET is quite a good way to get started on that actuarial front. Your next exam is on 10th January, as you can see on the screen, and the registration closes on 26th December. You can scan and register from here, or you can go to the IAI's website for it. And just if you're still wondering, why ACET or why actuarial science in general. So for actuarial science, I can go on and on why this is definitely one of the most growing and in-demand careers in India and across the globe. You have wide global opportunities, of course. The roles are high paying. Reason is because actuarial science, the type of content we learn, is universal. It's not like stats is different in India and it is different in, let's say, USA or UK. You have exactly the same logic, you have exactly the same skill set, and that's why it has a global sort of role. Number of actuaries are very, very low. Like for example, if I tell you in India, the number of chartered accountants in a country of 150 crores are 3.2 lakhs. Just 3.2 lakhs number of CAs we have in India at this point, which is a very small number. Now, wait for it. The number of actuaries, that is qualified actuaries in India registered with the IAI, are just 600. Like to the best of my knowledge, around 600, 550 to 600 was the number I had last seen. And that basically means that you have this career where there is a huge demand. Insurance companies, consultancies want actuaries to work with them, but the number of actuaries, that is a supply, is very low. And the result is the high paying jobs that you see, the scale of opportunities that you see, the kind of growth that you see for actuaries. So I hope if you were wondering, whether actuarial science is something that will actually help me in my career, I hope you get the answer through this. And as I said, whether you are apt for it or not, ACET is the best way to decide it. Okay. So on that note, we can now move to the next paper, which is the March 2025 paper. So let's look at the March 2025 paper. The pattern will be same only. You will always have logical reasoning questions at the end, and you won't have more than 7-8 questions, something like that, for logical reasoning. So let's see. Question 63, that is the first question of logical reasoning of March exam. It says in 2025, India's Republic Day, 26 January, falls on a Sunday, and Independence Day, that is 15th August, falls on a Friday. Okay. When will there be the first future year such that both Republic Day and Independence Day will fall on a weekend, Saturday and Sunday? Okay, so very interesting date related question. Here obviously you cannot add the number of days like we did in the August question, but there are some patterns you should know. One pattern is if 26th January is on Sunday and 15th August is on Friday, that is, you have, like, you go 2 days back from 26th January to August in a week, correct? So you just kind of go -2. This -2 will be there in all the years, correct? So if, like, say 26th January falls on a Wednesday in some year, in that year 15th August will fall on a Monday only, correct? So that 2 days gap will always stay. This is applicable in 2025, which is a non-leap year. So in a non-leap year, you will always have a gap of -2 days for between 26 Jan and 15th August, which means if it was a leap year, in a leap year, 26 Jan, whatever day it is on, let's say day 1, 2, 3, 4, 5, 6, 7 days of the week, let's say if it is on day X, 15th August in a leap year will definitely be on a day that will be X -1. And the reason is because you have an additional day in February, the days will be pushed after that by 1, correct? So for example, 15th August, which was used to be coming on a Friday, now because of instead of 28, you have 29 days in February. So all the days from March onwards shift by 1, and that is why in a leap year you can see that 26 Jan will be on a particular day and 15th August will be the day before that. Why is this important? Because the question is asking us to find out the year where Republic Day and Independence Day fall on Saturday and Sunday, which means there should only be a gap of 1. So we know that our answer will be a leap year for sure. It will be a leap year where 26th January falls on a Sunday and 15th August falls on a Saturday. Correct? This is what we need to find. Okay. Now how do we find this? So another pattern which you should remember is in all non-leap years. So whenever you have non-leap year, let's say 2025, if 26th Jan falls on a Sunday, then for a non-leap year, the next year, same date next year, that is 26 Jan 2026, this was a non-leap year, will fall on the very next day, Monday. And you can think about it, just try to look at your own birthday for example. every year the day of the week where your birthday falls on will go up by 1 for all the non-leap years. So even for example 27, this will be a Tuesday, and for 28, which is obviously a leap year, this will come on a Wednesday. So for the non-leap years, you see that it goes up by 1. Okay, but what about if it is a leap year? So that is now 2028 was a leap year. Now, if I talk about 26 Jan 2029, will it fall on the next day, Thursday? The answer is no. Again, because in 2028, you had February in between, which had 29 days. All the days go up by 1, which means now the gap will be of 2 days. So here, from Wednesday, this goes to Thursday and Friday. So in 2029, you will have Friday, that is, you will jump by 1. So I hope everyone is clear with the concept that non-leap years, the day on which a particular date falls on goes up by 1. After a leap year, that goes up by 2. Correct? And with this knowledge, now we want to find out a leap year where 26 Jan falls on a Sunday. So as you can see, in 2028, we have a Wednesday. The next leap year is obviously 2032, 2036, 2040, 2044, 2048. Let's first try and find for these. So you have Wednesday, then 29 is Friday, Saturday, Sunday, and this will fall on a Monday. Then you have Wednesday, Thursday, Friday. As you can see, I took a gap of 2 years after the leap year, 2 days after the leap year. Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Monday, Tuesday, Wednesday, Thursday, Friday. So here you will have Saturday, Sunday, Monday, and this will be a Tuesday. Another gap, so you have Thursday, Friday, Saturday, and 2048, you see 26 January falls on a Sunday. So this is how you have to think about it. Obviously, you cannot just randomly try and guess. You have to be very logical. You should know that the number of days difference is constant. In a leap year, if the two dates are on the other ends of February, 29th February, then that difference will be reduced. So 26 Jan and 15th August are on other sides, so the difference get reduced. Every corresponding year, normally the day goes up by 1. After a leap year, the day goes up by 2. Again, it depends on which side of February you are. So here, as you can see, for 2028, since it was 26th January, which is before the leap year, or before the 29th February date. That is why the day gets pushed by 2 in the next particular year. And then you just map out all the days on which 26 January will fall. 2048 is the leap year where 26 January falls on a Sunday. And accordingly, your final answer here is 2048, which means your answer here is after 2045 but on or before 2055. So here the answer is C. So quite important, quite interesting type of questions. Once you know the logic, quite easily doable. Otherwise, it may get very difficult in exam. Okay. So as a question 63, a relatively difficult one. We now move to question 64. So it says starting from sunrise, which is at 6:10 a.m. at some place, the number of times when all three hands of clock point exactly to one of the 12 numbers over a 24-hour period is. Okay, so normally, obviously your clock is something like this. You have 12 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this is, so 1 would be here, this is 12, this is 1. Okay. So this is like your normal clock, and you are being asked that how many number of times in the 24-hour span will all three hands be on a particular number. Now this is actually kind of a trick question, because if you think about it logically, leaves, you will have a seconds arm, you will have a minutes arm. These are fine, they will keep on crossing the numbers, but the hour, that is the hour hand, that will be on a particular number only at that particular time. So for example, the R hand will be on 3 only when it is 3 a.m. or 3 p.m. correct? Because at this point R hand will be on 3. After that it will be between 3 and 4. So R hand will be on 1, 2, 3 and so on only on those particular times. And obviously at 3 am, sharply at 3 am, your seconds and minutes hand is on 12 exactly, correct? So that is why you can say that it's the R hand which is what you need to focus upon in a span of 24 hours, any 24 hours. This 6:10 am is just given to confuse you, but in a span of any 24 hours, the R hand is on a number exactly 24 times, correct? So you can imagine from here at 7 o'clock, 8 o'clock, 9 o'clock and so on till next day 6 o'clock. The R hand will always be on one of the numbers, and that simply means that the 3 hands will be on a clock will be exactly 24 times. That is, your answer is option A. Okay. So the answer is E. So kind of a trick question just to confuse you, but if you know your concept of this, that the R hand is the real one, then it should be good to go. Perfect. So with that, we move to the next question, question 65. So it says all signs of an n by n cube are painted pink for some integer n greater than 2. So n could be 3, 4, 5, we don't know. The cube is then divided into n cube unit cubes, all of dimension 1 by 1 by 1. Then which of the following is independent of n? Okay, so an interesting question. Let's see. 65. So you have n by n cube. Okay, so this n could be 3, 4, 5, 6, anything. So a cube like this. Let's say 3 by 3 for now. 3, 3, 3. Okay. We have painted everywhere, we have painted it as pink. Okay, and then we have kind of removed the cube, like you just imagine a Rubik's cube. So we have removed the cubes into n cube unit cubes. So here when you remove these cubes, that is just extract 1 by 1 by 1 cube, this obviously has a volume of 27. We want to remove n cube cubes, that is we will create 27 cubes, all of volume 1 by 1 by 1, so 1, correct? So when we have 3 by 3 by 3 cubes, we will remove 27 cubes out of them and all of them will have a volume of 1. Okay, what are they asking now is which of the following is independent of n, and look at the options. Number of unit cubes with exactly 2 sides pink, number of unit cubes with exactly 3 sides pink, number of unit cubes with exactly 1 side pink. Now what are they trying to imply here? See, you painted this cube from outside as pink. Now when I create 27 cubes out of it, just try and visualize. For example, this will be a cube, this will become a cube, and this again will become a cube, like from below, correct? Just trying to extract one side. So these 3 cubes will be like just small cubes. If you think about it, what I've painted pink, so on cube 1 you will have 3 sides which have pink color, correct? That will be the side facing you, that is this particular side, the side facing on the left, this particular side, and the side facing on top. So they will have 3 sides pink. Same logic will apply for the bottom cube, that is the bottom cube will have 3 sides pink, and the middle one will always have only 2 sides as pink. Okay, the one in the center, that is there will be a cube extracted from here, here, the center cubes. So I'll just write here, these are the edge cubes, these are the side cubes, this is the edge cube, and this is the center cube. Center cube will always have 1 side as pink, correct? So just try to extract, like this is C, this is an edge cube, this is also an edge cube, and this is a side cube. This is again a center cube, this is a center cube. So the center cubes will have 1 side pink, the edge cubes will have 3 sides pink, and the side cubes will have 2 sides pink. Okay. Now we want to know what will be the number of two-sided pink or three-sided pink or one-sided pink. So in a 3 by 3 by 3, you can imagine these sides in a 3 by 3 by 3. So on one particular axis of the cube, you only have one side which is like the side cube, correct? Comparing this to, let's say, a 4 by 4. So I have another cube, and this is, let's say, a 4 by 4 cube. If I had a 4 by 4 cube, can I say that the number of sides, this will be an edge cube, this will be an edge cube, and then there will be two side cubes here. So in a 3 by 3 cube, I have on each edge one side cube. On a 4 by 4, I have two side cubes. Similarly, if it would be 5 by 5, I will have three side cubes on each edge. So the idea is, these numbers, that is number of side cubes, are related to n for sure. This is, in simple terms you can understand, this is 3 minus 2, this is 4 minus 2, and in general sides 1 will be a factor of n minus 2, right? For each side you will see this, for each edge. So you will have n minus 2 side pinks, which means two sides pink is definitely not independent of n. Okay. What about one side pink? Again, the center cubes will be dependent on the length of the cube, because in this one, as you can see, you only have one center cube for all the edges. In the 4 by 4, you can try and understand, there will be 1, 2, 3, 4 over here, and then you will again come to the side cube. So you will have C, 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 C. So you will have 4 center cubes here. Here you only had one center cube. In fact, when you go to a 5 by 5, you will see there will be around 9 center cubes. So how do we get these numbers? So this number of center cubes, I can just tell you here. Here you had one center cube on each side. Here you have 4 center cubes on each side. The next one will have 9. Number of center cubes will always be n minus 2 square. So you will have square of n minus 2. So here it is 3 minus 1 square 1. Here it is 4 minus 2 square, that's 4. The next one will be 5 minus 2 square, that will be 9, and so on. So again, number of single side pink is also a factor of n. Now let's focus on the three-sided pink. So three-sided pink are these edge cubes. So here you had on one axis you had 1 and 2 edge cubes. In a 4 by 4 also on one axis you had 1 and 2 edge cubes. In fact, no matter how big the cube is, you are only extracting the corners, and those corners will be exactly the same regardless of the size of the original cube, and that is why number of cubes with three sides pink is your correct answer, because that is not dependent on n. So the answer here will simply be number of cubes with exactly three-sided pink. So three-sided pink, that is your edge cubes, they will not be dependent on n at all, correct? So again, an interesting question. If you understood the concept, then it was quite straightforward to follow. Otherwise, you'll have to visualize a cube and try to relate to this. Okay. So let's move to the next one now. So question 66 says, folklore considers sun to be one's father's father and moon to be one's mother's brother. Assuming this is literally the case, which of these are a married couple? Interesting. So again, instead of trying to make a mental note, let's create, so you have one, he has a father and he has a father, and this father is nothing but sun. Okay. And moon is one's, so one has obviously a mother and mother's brother. So mother's brother, that is moon. Okay. So now we are asked which of these are a married couple. So first option is sun's daughter, moon's father. Sun's daughter is nowhere in the picture, so that is definitely not the answer. Sun's son and moon's mother. So sun's son, that is this guy, and moon's mother, who is again not in the picture, so not the correct answer. Sun's daughter, moon's brother. Sun, again daughter, nowhere to be found, so not the answer. Let's do the last option, sun's son. So sun's son is this guy, and moon's sister is this guy, this one, mother. So they are definitely a married couple, and the answer is obviously option D. Correct? So again, no need to overthink a lot. Just create this chart, try and work out the options, and you will get your correct answer. Very good. So with that, now we move to the next question, question 67. So it says 5 persons, Mrs. and Mr. X, Mrs. and Mr. Y, and Mr. Z are supposed to stand in a straight line for a group photograph subject to the following conditions. So X, Y, and Mr. Z, 5 people, 2 females, 3 males. No 2 adjacent individuals can be of the same gender. No 2 adjacent individuals can be a couple. Whose position is completely determined by these constraints. Okay, very interesting. So let's look at this. Question 67. 1, 2, 3, 4, and 5. What are they told? That Mr. and Mrs. X. So 2 females cannot be next to each other. 3 males cannot be next to each other. Okay. When I say 3 males cannot be next to each other, can I say the first, third, and fifth has to be a male, and the second and fourth has to be a female? Quite straightforward. Why? Because you want no adjacent of the same gender. So this is the only way in which you can arrange these 3 males so that they are not adjacent to each other. Okay. So male, male, female, female. Okay. Now the next constraint is no adjacent individuals can be a couple. Okay. So for example, if this is X, then this cannot be X. If this is Z, then this cannot be Z. Y. So if this is Y, X, this cannot be X. That means it could be Y, for example. So let's assume this is X, this is Y. Then here you cannot have Y. You also cannot have X because X is already aligned. Correct? So here you definitely have Z, and over here then you will definitely have X, and here you will have Y. Now understand, X and Y can interchange their positions. Y could come here, this X comes here, this Y goes there, but the Z always has to be in between. Correct? So because as you can imagine, in this entire nice group of couples, this guy is the only loner, and you don't want the couples to stand next to each other. You don't want people of same gender stand next to each other. So Mr. Z has to be that guy who is in between, who will ensure that couples and genders are both sort of apportioned. Okay, and that's exactly what we see. So here look at the options. Mr. Z, Mrs. X and Y, are they fixed? No. See, I'll just rewrite the other option in red. So for example, this could be Y, Mr. Y, which means this would be X, which means this would be Y, and this would be X. Correct? Same pattern, like they follow all the same rules, but a different pattern. Correct? So in all cases, Z has to be in between. So only Z's position is fixed, and that will mean that the answer is option A. So your answer is A. Correct? So hopefully this was understood. Now with this, let's move to the last 3 questions of the day. So it says, if all runners are athletes, all athletes are scientists, and no athletes are mathematicians, then which of the following is true? And then you have 2 conclusions. So let's see. All runners are athletes. Very carefully. So all runners, this is the runners, all of them are athletes, which means athletes is a circle outside of this. Sorry. So all runners are athletes. The opposite is not directly true, right? All athletes are not runners. Athletes could be others, but all runners are definitely athletes. Okay. And all athletes are scientists, which means there is an even bigger circle outside of this, which says all athletes are scientists, which means there could be scientists who are not athletes, but all athletes are scientists. Okay. And no athletes are mathematicians, which means no athletes are mathematicians. So there exists a circle which can overlap with scientists, right? Scientists, there could be scientists who are not athletes but are mathematicians. So there could be this external circle that sort of overlaps the scientist circle but not the athlete or the runner circle at all. Okay. So now let's see which of the following conditions are true. First, no scientist is a mathematician. That's not true, because as you can see here, scientist could be a mathematician. If the scientist is not an athlete, they could definitely be a mathematician. No mathematician is a runner. So no mathematician is a runner, and that is true because as you can see, mathematicians cannot be athletes because no athletes are mathematicians, which means mathematicians can definitely not be runners because all runners were athletes. So conclusion Y is true, X is not true. So only Y is the correct answer. That is, answer is option D. Conclusion Y is true. Okay. So I hope this Venn diagrams kind of makes sense. Again, you can try other ways also, but this is a sure shot way of trying to sort of get to the answer. You just have to be very careful in creating those veins, right? Like it's very easy, for example, for someone to create the mathematician circle outside the scientist circle completely. But that's not what we are being told. We are told no athletes are mathematicians. So it's the athlete we are saying that are not mathematicians, but scientists can definitely be. Okay. So we move to the next one, that is question 69. So arrange the following words in a meaningful sequence. Treatment, symptom, diagnosis, cure. Okay. So obviously first, logically, for any illness, let's say fever, first you will see there are some symptoms that you may be feeling tired, you may be feeling warm. So that's your symptom. Then you will basically go to the doctor, you will get a blood test, so you will get your diagnosis. After which the doctor will prescribe you paracetamol or Dolo 365 or something like that. That is your medicine. So that's P. And finally you will be cured of your illness, that is S. So QRPS. So just create a story. No need to confuse yourself with a lot of English words. Just create a story in your head and you should be good to go. So QRPS, that is option C. Okay. So that is a meaningful sequence. Obviously, this sequence is quite hard and fast. Right? Like one cannot be before other. It cannot be that you were diagnosed with the disease first and then you found the symptoms. Correct? That's basically confirmation bias. No. Logical sequence. Okay. Question 70. Again a sequence one, but with a little twist. So we are told find the wrong number in the sequence. 1, 3, 9, 33, 163, 873, 5913. Wow. Okay. So what is happening here? Okay. So you have this series that is 1, 3, 9, 33, 163 and so on. Let's try and find a pattern first. So it is a find the wrong number in the series, right? So you have to be a little careful here. First, let's look at the options. So 33, 163, 873, 5913, which means it says one of the last 4 could be wrong, which means first 3 are definitely right. Okay, so we can try and figure out a sequence between the first 3 or first 4 numbers and then try to extrapolate it. Okay. As I said, for sequence, the first thing you should always do is try and look at differences. So what are the differences? Difference is 2, 6, 24, and maybe if I just go till here, then here it is 120 and rather 130 over here and so on. Okay. Now let's try and see if there is a relation between these. So 2 into 3, that's 6, into 4, that's 24. Okay, so you can see that if I multiply this with 3, I get 6. If I multiply this with 4, I get this. Ideally, if I would have multiplied this with 5, I should have gotten 120 over here, but I have 130. 163 could be the wrong answer, correct? But let's then try to see if this logic applies for the next numbers. So you have 873. Okay. What is the current difference between 873 and 163? So we can try and see that this is 710. Now, if our logic was correct, so I'll just try and create an alternate this thing. So if our logic was correct, that is instead of 130, you had 120 over here as difference, which means instead of 163, you would have 153 here. Okay. and the difference between 153 and 873 would be 720. 120 multiplied by 6 is 720, which means 720 multiplied by 7 should be the next difference. 720 multiplied by 7, that is 4900, and 140, that is 5140, and 873 plus 5140 would give me 5913, which is exactly what we have, correct? So this means that our sequence was simply, you have the difference, and these differences are basically multiplication of the previous one with an additional number. So 2 3s are 6, then 6 4s are 24, 24 5s are 120, 126 are 720, 727s are 5140, and these are your differences. If you understand, actually what we are saying is these numbers are basically some of the factorials. So this is 1 factorial, this is 1 factorial plus 2 factorial, because that's what we are doing, right? 2 into 3 and all of that. This is 1 factorial plus 2 factorial plus 3 factorial, 1 plus 2 plus 6. This is 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. So you can see this difference is 2, 6, 24. What are these? This is 2 factorial, this is 3 factorial, this is 4 factorial. So similarly here you should have 5 factorial, but you have 130 instead, and that's because 163 is the wrong answer, correct? So that is how you have to try and apply the logic. As I said, always find the difference first and try to see if there is a logic there. We could see there is a logic here, which means 163 is the odd man out, and that means your answer is option B. Okay, so option B is the wrong number in the series, so to say, correct? These type of questions are a bit difficult, are a bit challenging, but given the right thought process, you should be able to find them. Perfect. So that was your March 2025 paper. We now move to the next one, that is December 2024. So let's see. We start with a date type question. So it says today is 21st December and it falls on a Saturday. The next time 21st December will fall on a Saturday will happen in. So you have to apply the same leap year logic which we had seen earlier. Let's see. So this is question 63. Now you're starting in a leap year itself, 21st December 24. But the impact of leap year is already gone, right? It happened in February. Now after this there is no additional day between this and the next year. This is on a Saturday. So 25 will definitely be on a Sunday. This you have a non-leap year impact. 26 Monday, 27 will be on a Tuesday. Then you get to 28. So 21st December 28. Understand, between 21st December 27 and 21st December 28, you will have an additional day. That is 29th February 2028, the leap year. So instead of Wednesday, now here you will have Thursday. Remember the question is, when will 21st December fall on a Saturday? So we have come to Thursday. Friday 30 will be Saturday. 31 will be a Sunday. We just wanted when it will fall on a Saturday. So we already found that 2030 comes on a Saturday, and that is your option D. So that's it. That's how you have to find it. Look at the question, try and extrapolate year after year, and you should be able to get the correct answer. Okay. So if no issues here, we move to the next one. So it says question 64, a 3-hour exam starts in the morning at time T1 and ends in the afternoon at time T2. Interestingly, the clock at time T2 is a mirror image of that at time T1. Then T1 equals what? So instead of trying to figure out a lot of numbers, let's just look at the options that they have given. Okay. So question 64, let's try to draw the clocks. At 10:30, if 10:30 was T1, that means your exam is getting over after 3 hours, which means 11:30, 12:30 and 1:30. How does the clock look at 10:30? So obviously you will have your hour between 10 and 11. So 10 would be here, 11 would be here, 12 would be here, and the hour hand will be between 10 and 11, exactly in between. because it is 30, your minute hand will be at 6 and the seconds will definitely be at 12. And what about 130? So you have 12, 1 and 2, and here it will be 3. So the hour will be between 1 and 2. The minute will again be at 6, and the seconds hand will be at 12. So as you can see, this is actually the answer, because you can see this is a very clear mirror image. That is your hour hand from left, it just went to the right hand side. You can try the other options as well, but I'm sure you will not be able to get the same type, because at 10, for example, just to show you an example, 10, your hour hand will be here, rather your hour hand will be here, and your exam finishes at 1, which will be your hour hand will be here. So you can see this is not a mirror image. The mirror image of 10 would be 2. That's why. So 10, 30 and 130 is the correct answer, which is option A. Here we were lucky enough to find the answer in option A itself. Otherwise you would have to create 3 such images, and you can just see which one is the correct one. Okay. So that's question 64. We now move to question 65. So again you have a n cube type of question. So all sides of a 5 by 5 by 5 cube are painted red. The cube is then divided into 125 unit cubes. Let x be the number of unit cubes with no red sides. Okay. Y be the number of unit cubes with exactly 1 red side. Z be the number of unit cubes with exactly 2 red sides. Then which of the following statements is false? Okay. So just quickly to recheck, we have 125 by 125, rather 5 by 5 by 5 as the sides or dimensions, which means 125 is the volume. So you create 125 cubes out of them. Okay. We can clearly see the sides painted which will have 3 sides painted, which were the edge cubes earlier. So you will have 1, 2, 3, 4, 5, 6, 7 and 8. So 8 cubes will definitely have 3 sides red. Correct? And this will be true, we saw in the earlier question, this will be true regardless of the dimensions. No matter what dimensions are there, 8 corner cubes will always have 3 sides as red or pink, whatever the paint was. The number of cubes with 2 sides red will always be, if you remember, n minus 2 on each arm. So here you have 1, 2, 3. Similarly 1, 2, 3, 1, 2, 3, 1, 2, 3. This will happen on each arm, and that is each vertex, and there are 12 vertices in total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So you have 12 such things. So in fact the total number of cubes with 2 sides painted would be 12 into n minus 2, which in our case will be 12 into 5 minus 2, that is 36 cubes where you will have 2 sides as red. So 2 sides red, you will have 36 cubes. And finally, if you remember the one side thing, so one sided painted, these are the central cubes. So you will have n minus 2 square cubes in each of the side or each of the surface. So you have 6 surfaces. Each surface, just here you can see, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 central cubes in one surface, and you have 6 such surfaces. So n minus 2 square into 6, which is 6 into 9. So you will have 54 cubes which are one-sided red. Correct? And then you can just find the balancing figure that, okay, 8 cubes with 3 sides red, 36 with 2 side, 54 with 1 side. So how many cubes have no side painted as red? These are your internal cubes. So you can just see 8 plus 36 plus 54, that is 90 plus 8, 98 cubes have at least one side red, which means 125 minus 98, that is 27 cubes will have no side as red. No side red, and these are all your internal cubes. Okay, So x was number of cubes with no side, right? So x is 27, we clearly see. Y is basically 54. Z is two sides, so that is 36. So your first one is x plus y plus z is divisible by 9. Now x is divisible by 9, y is divisible by 9, z is divisible by 9. So this is true. We can just check. Y plus z is 3x. What is y plus z? Y plus z is 90, and that's not 3x. 3x is 81. So this is not true. LCM of x, y and z is 108, and you can see that is the case because x into 4, that's 108, into 2, that's 108, into 3, that's 108. So the lowest common multiplier of all three of them will be 108. There's no other one which all three of them are a multiplier of. And then lastly, y is greater than z, which is greater than x, and you can see that is the case because y is greater than z, which is greater than x. So A, C and D are true. Which of the following are false? So B is definitely the false, and therefore your answer is B. So I hope you guys understood this. This cube one is a repeated question, so just remember this logic of n minus 2 square and all of this, and you should be good to go. Okay. So again, the father mother type question has come up. So if x's mother's father is married to y's father's mother, then x's father is y's mother's what? No need to think so much. Let's just create a nice family chart. Okay, so question 66. X's mother's father. So x obviously has a mother who has a father. Okay. And this guy is married. So this guy is married, like the mother, which would be mother's mother. So just his wife basically is y's father's mother. So y has a father whose mother is this one. Okay. So x's mother's father is y's father's mother. Okay. Then x's father, that is x's father, is y's mother's what? So now here you can clearly see that x's mother's father and y's father's mother. So this is the same couple, which means this person and this person are brother and sisters, right? So this is the sister and this is the brother. Okay, and we have to find the relation between this person and this person. That is x's father, person 1, is y's mother's person 2. So who is x's father? We can just try and figure out here. So y's mother's husband. So husband's sister, husband. So husband's sister's husband. So y's mother's husband's sister's husband, that is x's father. So do we have that option? Yes, option C, husband's sister's husband, and accordingly the answer is option C. Okay, so these type of family tree questions could get confusing. You either create this chart, or as I said, just try to apply it in your own family tree and you will be able to understand it. Just give some name to x and y. You could be x, then try to see who could be y, and then try to figure out the relation accordingly. Okay, so let's come to the next question, question 67. So it says again that table 1. So four couples wx, y, z, each comprising a lady and a gentleman, are seated on a round table, and then are given some conditions. Okay, so it's a round table and there are 8 people, right? So there are 8 people. Right now let's not try to plot anywhere, because let's first look at the question. It says that Mr. and Mrs. X are not sitting next to each other. Okay. Mr. and Mrs. Z are sitting next to each other, and Mr. and Mrs. W are sitting exactly opposite to each other. Which of the following statements is not necessarily false? Okay, so let's try to first look at these points and then work our way back to the question. So the first question is, each gentleman is surrounded by a lady on both the sides, to his left and his right. Okay, for that to happen, you would have a sequence like this, that is male, female, male, female, male, female, male, female. Correct? These are 8 people. 1, 2, 3, 4, 5, 6, 7, 8. This is the only sequence in which this is possible, that each gentleman is surrounded by a lady to his left and right. Which means, if you just see, opposite of a male will always be a male and opposite of female will always be a female. Is this possible? The answer is no. Why? Because Mr. and Mrs. W are sitting exactly opposite to each other. So there is a couple who are sitting exactly opposite to each other. So option A is definitely false. Okay. So A is certainly false. Now let's look at the option B. It says none of the Y is seated next to an X. So what are we told about X? That Mr. and Mrs. X are not sitting next to each other. Okay, so if Mr. and Mrs. X are not sitting next to each other, we know this is first of all not the case because W's are opposite. So we have to switch one of them. Let's say, for now, I'll just switch these two. That here you have a female and here you have a male, correct? This could be Mr. W, this could be Mrs. W. Now, what are we told? That Mr. and Mrs. X are not sitting next to each other, okay? So these two cannot be X, these two cannot be X, and these two also cannot be X. So like they cannot be corresponding is the real point, okay? So if this is Mr. X, then Mrs. X would be either here or here, okay? So Mrs. X could be here or she could be here, but she is definitely not here, which means where is Y? So, and on top of that, we are also told that Mr. and Mrs. Z are sitting next to each other. So X, okay, if X is here, then Mrs. X is here or here. But then what about Z? Because if Z's are next to each other, and this is how W's are seated, then this is definitely Z, and this or this could be Z. Okay, so here you could have Z, Mrs. Z, here you could have Mrs. Z, which means either of these two could be occupied by Z. One of these, like the remaining one, is occupied by X, and Mr. X is, for example, here. This is one way in which this can happen. Z's could be here also, which means X would be on the other side, and things like that. Okay. But now what are we told about Y? That none of the Y's is seated next to an X. Now this, I don't think so this is possible, and you can check this also. Why? Because here, what are the positions left? If this is the sequence that Mr. X is here, Mrs. X is here, okay, this is Mrs. X, this is Mr. X, this is Mr. Z, this is Mrs. Z. Where would Y sit? Y would be here and here, and they are definitely next to an X. Even if you take the other option, that is, you can put X here, Z's here, something like that, again you will see that Y will definitely be next to an X. So option B is also definitely false. None of the Z's is seated next to a W, because W's are sitting on the opposite side and Z's are sitting corresponding to each other. They have to be seated in either this one, or this one. These three are the only options, and all three options over here are next to a W. So option C is also definitely false. So that only leaves us with option D, and it says there are an even number of individuals seated between Mr. and Mrs. X. So where could be Mr. and Mrs. X? If Mr. X is here, then Mrs. X could be here or here, correct? Let's see the number of people between them. So here you have 1, 2, 3, and here you have 1, 2, 3, 4 in between, right? Here you have 1, 2, 2 in between. Here you have 1, 2, 3, and 4 in between. Okay, so here you could have even number of people in between, which means D is definitely not a false, and that's what we are asked, right? A, B, and C we realize are definitely false. D may or may not be false. So at least in this scenario you can see it is not false. So that simply means the answer to question 67 is D. Correct? So that's how you have to figure out, look at the options, look at what the question is saying, and try to work out a way. Okay, so that's question 67. With that, we move to question 68. The Venn diagram one. If all dancers are singers and no singers are painters, then which of the following is true? So it seems like a straightforward one. Let's see. So question 68. it says all dancers are singers. So you have a Venn diagram of dancers and they are all singers. Opposite, not necessarily true. All singers may not be dancers, right? No singers are painters. So there are painters, but no singers. Like none of these guys is a painter. Okay. So you have an entire Venn diagram of painters and none of them could be singers. There cannot be a single overlap over here. Okay. No singers are painters. Then which of the following condition is true? No dancer is a painter. Yes, no dancer is a painter because dancers come under singers. So no dancer is a painter for sure. All singers are dancers. All singers are dancers, absolutely not the case. There would be singers who are not dancers. So X is true, Y is not true, which means only X is the correct answer. So answer is option B. Correct? Simple Venn diagram. Just try and corroborate with the facts and you will get the conclusion. Very good. That was question 68. We now move to question 69. Arrange the following words in a meaningful sequence. We'll again try to build a story here. So you have punishment, crime, judgment, arrest. Okay. So question 69. Let's think of a crime. Let's say I steal something. In that case, this would be the case. So if I'm stealing something, the first would be the act of stealing, which is the crime. So Q is first. Then I will be arrested because the police will find, okay, I was the one who stole it. So I will be arrested. Then I will have a court hearing, and in that court hearing, there will be a judgment that, you are, for example, jailed for 5 years. And then I have to actually go to jail for 5 years, which will be my punishment. So this is the logical sequence, that is crime, arrest, judgment, and punishment. QSRP. So QSRP, that is option B. Okay. So option B, which is the correct answer over here, that's QSRP. And finally, we again have that wrong number type question. So find the wrong number in the sequence 1, 5, 14, 30, 55, 90, and 140. Okay. So as I said, first always find the differences. So 1, 5, 14, 30, 55, 90, 140. Let's look at the options. So 14, 55, 90. So it's either 14, 55 or 90. Either of these three are wrong. Okay. So 1 and 5 is definitely not wrong. 30 is definitely not wrong. So let's try and create a sequence between them. So first difference is 4. Here the difference is 9. The difference is 16. I hope you can start seeing the pattern already. 16 and 55, the difference is 25. 25 and 90, the difference is 35. So you can see that the differences have a clear pattern. This is a perfect square, this is 2 square, this is 3 square, this is 4 square, this is 5 square. Now this is supposed to be ideally 6 square. That is, this should ideally be 36. So let's try and create that alternate series. That if this was 6 square, this would be 36, which means this would be 91. And then the next difference between 91 and 140 would be 49. 49, which is nothing but 7 square. So we can clearly see that this difference is wrong, which means this is the wrong number. So 90 is definitely the incorrect one, which means the answer is option C. So here you simply have the option C, which is 90. It should be 91. Okay. So with that, we are done with another attempt of paper. And now we can move to the last attempt, that is October 2024 for the day. So let's start with the first question here. So it says, if in 2023 your birthday fell on a Sunday, you will celebrate your birthday in 2024 on a ABCD. Now this is a very interesting trick question. Question 63, and this kind of covers the point we have been trying to make. Okay. Your birthday was on a Sunday in 2023. Okay. Now there are two options here in 2023. That is, your birthday was either before 29th or 28th February, or it was after 28th February, that is 1st March or something, correct? So if it was before and it was a Sunday in 2024, between your two birthdays there was no leap year, so then in 2024 your birthday will definitely be on a Monday. However, if your birthday was, let's say, on 1st March, okay, in 2023, and that was a Sunday, in 2024 1st March will have an additional day in between, that is 29th February, and this will accordingly have become Tuesday. So your birthday could be on a Monday or a Tuesday, you cannot be sure because this is a leap year gap. So that is why the answer is very nicely D, that is you cannot be sure. And you can see, to confuse the question, use both the answers, Monday and Tuesday. Now don't fall into the trap of thinking when your birthday exactly falls, because that's not what they are trying to ask. Your birthday could be after or before, but that's not what the point is. The point is you cannot be sure. Okay. So that's question 63. We now move to question 64. So it says between noon and midnight, that is in 12 hours, and not counting those two instances, how many times will the minute hand exactly overlap with the hour hand on a clock? Okay, so this is a very nice one. Question 64, and all it says is, between midnight and noon, that is at 12 o'clock basically. At 12 o'clock, I hope you know that the hour, minute and seconds, they are all on the same one. So between noon and midnight, not counting these two instances, these two we don't need to count. How many times will the minute hand exactly overlap the hour hand on a clock? Now, one thing you should know, that in every 1 hour, 1, 2, 3, every 1 hour, the minute hand completes an entire circle of the clock. Correct? The minute hand will start from 12 and it will end on 12. So the minute hand completes an entire circle in every 1 hour, which means between 12 and 1, there will be at least one time where the hour hand and minute hand overlap. Correct? At least one time. We don't even need to find the time, but there will at least be one time when this happens. Similarly, between 1 and 2, there will be at least one time. 3, 4, 5, 6, 7, 8, 9. Between this and 10 you will have 10 times, and 11, and finally between this and this there will be a 12th time between 11 and 12, that is the minute hand will cross the hour hand. But you have to be careful over here. The time between 11 and 12, when this actually happens, that is the minute hand crosses the hour hand, is exactly at 12 o'clock only, and we are told that we have to ignore that instance. So between 11 and 12 it does not happen, it happens exactly at 12, which means this one we have to ignore. So now we have to be careful that the 12th time it happens we will not consider, simply because it happens exactly in 12. And also the first time it happens, that is between 12 and 1, that is also exactly at 12 o'clock only, because after that, once the minute clock starts, the hour obviously follows it and it will go till 1, while the minute clock has come to 12 again. So this first time and the 12th time, they both happen exactly at 12 o'clock. So they both happen at 12, and these are the two instances we don't need to count. So that is why you can see that the number of times this overlap happens is 12 minus 2, that is 10, and your answer is option A. Okay. So hopefully that was clear. It's an interesting question. You need to understand exactly how that clock works, but the answer is option A, 10 times, excluding the 2 times that it happens at 12 o'clock. Perfect. So with that, we move to the next one, question 65. So again, you see a red cube question, painting type question. So it says 5 sides of a 5 by 5 by 5 cube are painted red. Wow. And the remaining one side is painted blue. Okay, there are a total of 6 sides in a cube, 6 surfaces. The cube is then divided into 125 unit cubes. How many of the smaller cubes will have at least 2 sides painted red? Now 2 sides painted red. Okay, so let's try and see. So you have question 65, 1, 2, 3, 4, 5, 6. Okay. We already know that on its surface, for example, if I'm talking about this line, then we know that n minus 2 number of cubes in each line will have two sides colored. Now here the interesting thing is there is one side which is colored blue. So let's say the top one is colored blue, the rest all are red. Okay. So all the two sides which have red color on both the surfaces adjoining will have two sides painted red. Okay. In total there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we already know that two sides painted red should ideally be 12 into n minus 2, which in our case would be 12 into 3, that's 36. Ideally 36 should be the answer. But because here we have one surface which is painted blue, what will happen is the four corresponding sides will not have two sides painted red. They will have one sided painted red and the other side painted blue. So from 12 into n minus 2 there will be 4 into n minus 2 which will actually be painted blue, which is blue on one side and red on the other side. So that means 4 into 3, that's 12 out of this 36 which will have one side red and other side blue, and that's why in total we will have 24 cubes which will have two sides painted red. We have 24 cubes where we have two sides painted red. Now the question says that how many of the cubes will have at least two sides painted red. So these are the ones which have two sides painted red. We also need to find three sides painted red. Okay. So for three sides red, you would typically have in normal cases 8 cubes. Correct? These are the 8 corners that we take. But in this one, again you will have this corner, this corner, this corner and this corner. So 4 corners will have two sides red and one side blue. So these 4 corners will have 4 cubes will have two sides red and one side blue, whereas the remaining 4 will have 3 sides red. Now don't get confused. We have to count all 8 of them in our case, correct? Because we are told we should have how many number of cubes which have at least two sides painted red. Now agreed, these 4 cubes which are corner cubes which should have 3 sides, they now only have 2 red and 1 blue. But that still means that they have 2 sides which are painted red, at least 2 sides painted red. So we'll count this 4 plus this 4 plus this 24, that is your total will be 32. And do we have 32 as an option? Yes. So your answer is option B. So that was an interesting one. And now we move to question 66. So again a family tree question. It says if y is x's mother's father's son, then x is y's. I don't know, we can just create a nice family tree. So y is x's mother's father's son. So first let's start with x. X obviously has a mother. So x is mother's father. So x's mother has a father who has a son. And y is x's mother's father's son. So this son is y. So x's mother's father's son is y. Obviously this mother and y, they are brother and sister. So this is a sister and y is the brother of x's mother. So then x is y's. So x is y's what? Y's, we can just imagine sister's son. So do we have that option? So here you have options like sister's son. So you have nephew / niece, which is sister's son. So the correct answer is option C. Son or daughter, right? Because x, we don't know anything about x. So x would be son or daughter. That's why it's nephew or niece. Correct? So that's question 66. Let's move to the next one, question 67. So it says 5 cards numbered 1 to 5 are placed in a sequence. No 2 prime numbered cards are next to each other. The number on 2 cards that surround the card numbered 1 add up to 8. Which of the following statements is necessarily true? So let's try and create this sequence. 67. So 5 cards are placed in sequence. No 2 prime numbered cards are next to each other. Now 1, 2, 3, 4, 5. which are the prime numbers. So I hope you know 1 is neither prime nor composite. So 2, 3 and 5. Prime numbers are those which are only divided by themselves, and 1. They don't have any other multiplier. So these are not next to each other, which means I hope you understand that the sequence has to be prime, composite, prime, composite, prime. Now this composite, this could either be 1 or 4. This could either be 1 or 4. So these could be 1 or 4, 1 or 4. Okay. What else are we told? The numbers on 2 cards that surround the card numbered 1 add up to 8. So the numbers that surround 1, let's say if 1 was here. So the numbers on 2 cards that surround it add up to 8. Now there is only one option that does that, which is 3 and 5. So this would be 3 and this would most likely be 5. This could be 4 and this could be 2. There are other options as well, but let's go ahead with this one. And now let's try and understand which of the following statements is necessarily true. Okay. So we created one sequence. Are there other sequences possible? Yes. So I'll just write down the other sequences quickly in, let's say, red color. So we had 1 over here. The other option is you have 1 over here, but this is 5 and this is 3. Correct? That's the other option. 4 and 2 will remain exactly the same. The third option is if this is 4, then this would be 1, and here you will have 3, 5 and this could be 2. Or if this is 4, then this will still be 2 and here you will have 5, 1, 3. So these are the 4 alternates which are possible. Okay. Apart from this, no other possibility exists. So now let's read this question. So it says cards number 2 and 3 will have exactly one card in between. So let's see in all the cases what happens. 2 and 3. So here 2 and 3 have 3 cards in between. 2 and 3 has one card in between, 2 and 3 has one card in between, again 2 and 3 has 3 cards in between. So that's not necessarily true. So this is not necessarily true. Let's do the option B. Card number 1 is in the second position in the sequence. Again, not necessarily true. It could be second, it could be fourth as well. The product of numbers on any 2 consecutive cards is never more than 15. Okay, this is interesting. Let's come to option C later. Let's first do option D because that's an easier one. So cards number 2 and 4 are next to each other. So 2 and 4 will always be next to each other, and that is yes, because 1 is always surrounded by 3 and 5 and 1 is not on the edges, cannot be on the edges. So 1, 3 and 5, so 2 and 4 will always be next to each other. For completeness, let's look at option C also. So the product of numbers on any 2 consecutive cards is never more than 15. So first of all, to get more than 15, the only option is 4 and 5 could be next to each other. If 4 and 5 next to each other, the product is 20. And you can see in our option 1, 4 and 5 next to each other. In the fourth one also 4 and 5 next to each other. So that's why you can clearly see that C is also not necessarily true, which means D is definitely the correct answer. So answer here is option D. Okay. So just try to create all the possibilities because the question is not conclusive. Create all the possibilities in this case and try and see which one is definitely true. Okay. So with that, we move to the next question, question 68. It says if all alphas are betas and some betas are gammas, then which of the following is necessarily true? So again, just simply create your Venn diagram. All alphas are betas. So you have alphas and all of them are betas. So there is a circle of alpha and there is a bigger circle of beta. So all alphas are betas. Okay. Some betas are gammas. So some betas are gammas, which means there is a third circle which overlaps this entire circle, right? So there is a third circle which overlaps this entire circle and says that some betas are gammas. So out of some of those betas there are gammas. Gammas could be non-betas, and very importantly, gammas and alphas will also have an overlap because all alphas are betas. So there is nothing that is telling us that alphas cannot be gammas, correct? So we will have this overlapping circle. And now let's try to answer which of the following is necessarily true. If X is not gamma, he is also not alpha. So if somebody who is not gamma, that is you are not gamma, you cannot be alpha. But that's not the case because if X exists here, then definitely X is not gamma but he is alpha. So option A is not true. If X is not beta, he is also not alpha. If X is not beta, that is you don't exist in the circle of beta, you are not alpha. That is true because all alphas are beta. So if X exists outside the beta circle, no matter where he is, he cannot be an alpha. So this B is true. Now let's try and see if C and D also makes sense. Your answer is B, but let's see C and D also fun. If X is not gamma, he is also not beta. So if X is not gamma, he is not beta. Again, that is not true. If X exists here, he is not gamma, but he is beta. So C is false. And then finally, if X is not alpha, he is also not beta. If X is not alpha, he is not beta. Again, that's not the case. If X exists here, he is not alpha, but he is definitely beta. So C and D are not true. The only correct one is option B. So answer is option B. Correct? So that's how you can just create a Venn diagram and it should be quite clear. With this, we move to the last two questions for the day. That is question 69. In a group of 40 students, 20 are male and 24 have opted for Sanskrit. Then the minimum number of boys who opted for Sanskrit is very nice. So this is kind of that union question which we used to get in 9th or 10th grade. So you have total of 40 students, 20 are male, obviously 20 are female, that's fine. And 24 have opted for Sanskrit. So 24 have opted for Sanskrit. Okay. We have to find minimum number of boys who have opted for Sanskrit. To find minimum number of boys who opted for Sanskrit, you would first assume that all females opted for Sanskrit, right? So 24 of these 20 are female. If all 20 of them are female, that will still leave at least 4 people, and those 4 have to be male. That is, there are 4 boys who have opted for Sanskrit, correct? So that means the minimum number of boys who opted for Sanskrit is definitely 4. Answer is B. So you don't need to create any De Morgan's equation or anything like that. You can just look at this in a normal logical sequence and you should be able to find that. Okay? And with this, we now move to the last question for the day. Which of the following sequences is inconsistent with others? So this question is your geography in a way. Okay? So it says Mumbai, Maharashtra, India. So that's a city, a state and a country. Adelaide, South Australia, Australia. So that's again a city. This is an area, region in Australia and then Australia. The option D is Toronto, Ontario, Canada. Toronto is a city, Ontario is again a county and Canada is a country. But option sequence is quite clearly different. It says United States of America, that is the country is in the first sequence. California and Los Angeles. Los Angeles is a city, California is a state. So you can clearly see that option C is not aligned with the rest of them, and that is obviously the odd man out. So with that, people, we are done with the last 4 diets of logical reasoning paper. I hope you saw the idea in this masterclass that there are certain types of questions which are repeated almost every diet, like that cube question, the mother, father, sister, that type of a question, the Venn diagram question. So these are questions which are repeated multiple times, and the best thing is, if you practice enough, you will have a good conceptual clarity on them, and then a similar type of question, if it comes in the exam, you know exactly how to approach it. So that's the key takeaway in logical reasoning. It's one of the fun part of ACET, but very important as well. There are around 8 questions in each diet from this one, ranging from 10 to 15 marks, I believe, and definitely achievable, right? You could see today that once we know the basics, we are definitely able to find them. Even that date question is something that is quite common. So just be clear with the concept of those and you should be good to go. So with that, people, thank you so much for attending this masterclass session. All the very best for your ACET examination, and I hope to see you guys soon in the actuarial circles later. So thanks a lot.